Hi friends, let's do some practice problems in statistics. So basically the bar graphs, the histograms, the frequency polygons that we have studied before fall under the area of statistics, which is a data science where data is collected, studied, the mean, that is the average, the median, the mode, all other statistical values and graphs are visualized. Okay, so let's take a first problem, bar graphs for votes. So we have political parties A, B, C through F, and each of them have the votes given in the table. Political party A has 175 votes in the election, B has 155, and so on and so forth. So this can be visualized in a bar graph. So basically political parties are on the x-axis and votes are on the y-axis. So political party A gets 75 votes. You can see the bar is pointing that it is getting 75 votes. Similarly, another bar for B is saying that it has got 55 votes. Similarly, C has got 37 votes. D has got 29 votes, which is almost 30, and E has got 10 votes, and F also has got 37 votes. So by looking at this graph, you can easily figure out that party A is the winner of the election. Okay, so that is problem number 1. Let's look at problem number 2, where we want to draw a histogram of leaves lengths. So length of the leaves. So we have got the length, let's say 118 to 126. There are 3 leaves among all the leaves we collected. 127 mm to 135, there are 5 leaves. 136 to 144 mm, there are 9 leaves, and so on and so forth. Now remember, to plot a histogram you need continuous intervals. Okay, so you can see that 118 to 126, after that the interval starts from 127 to 135. So how do we make it continuous? We just extend 0.5 on either sides. Okay, so instead of going from 118 to 126, we go from 117.5 to 126.5. Similarly, for the second interval, instead of going from 127 to 135, we take it from 126 to 135.5, and so on and so forth, and make it continuous. Okay, so this enables us to use continuous values on our x-axis and hence plot a histogram. Because for a histogram, note that x-axis variable should always be continuous, right? There should not be any break. It should be a continuous. It should not be discrete like the bar graph. It should be continuous. So let's plot it now. So length mm on the x-axis, we have 117.5 to 126.5, 126.5 to 135.5, and note that each unit is 9 units, 9 millimeters in length. So from 117.5 to 126.5, it's 9 mm. 126.5 to 135.5, it is 9 mm, and so on and so forth. Okay, so in this, and number of leaves can be plotted along the y-axis, right? So in this, we have from 117.5 to 126.5, we have 3 leaves. Next interval 5 leaves, next interval 9 leaves. Okay, so 135.5 to 144.5, next interval 12 leaves, right? Next interval 5 leaves again, then 4, and then 2 leaves. Okay, so looking at this data, we can say that the median or the midpoint of all the lengths of the leaves is somewhere between 144.5 to 153.5. okay, so that is the midpoint. If you take all the leaves and sort them in ascending order of their lengths, the midpoint will be somewhere between 144.5 to 153.5. okay, that is what we gather from this histogram. Let's look at the next problem. Problem 3, frequency polygon marks comparison between section A and section B. Okay, here we have got marks range 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, etc. And you can see that here it is continuous. So for histogram and frequency polygon, the ranges must be continuous. Here we have a continuous range because 0 to 10, and it continues from 10 to 20 and so on. Okay, in 0 to 10, section A has 3 students, whereas section B has 5 students. Similarly, between 10 to 20, section A has 9 students and section B has 19 students, and so on and so forth. Okay, now for frequency polygon, you need the midpoint of the ranges. Okay, so we have calculated that in column number 2. So column number 1 gives 0 to 10, which is the range, and midpoint of that is 5. Again, 10 to 20 range, midpoint of it is 15, and so on and so forth. Okay, so the column 2 gives you the midpoints, and section A and section B are giving you number of students falling in that range for section A and section B. So we can again plot marks range midpoint on the x-axis and number of students on the y-axis. So let's plot everything in orange for section A. So for section A, 5, the range which has midpoint of 5, there are 3 students. So we plot a 5, 3. Again 15, 9. Right, for the range which has 15 as the midpoint marks, there are 9 students. Similarly 25, 17. Okay, similarly 35, 12, there are 12 students in this range, and 45, 9. Okay, so the points are plotted. We connect them by the lines to get the frequency polygon of section A. Section B, let us put it in green so that we can compare. So here we have 5, 5, right, and again 15, 19, right. So in this range there are 19 students, and again 25, 15, right. So we have that. Then 35, 10, so we have a point there, and finally 45, 1, we have a point there. Okay, so and we just join it with lines to get the frequency polygon of section B, which is in green. Now if you want to compare these two classes, note that the number of students in the higher marks like 25, 35 and 45 are more in section A, which means more students have performed and got better marks in section A. See, for the marks which fall in the range around 5, of course section B has more students because green is above orange. Similarly for 15 also, green is above orange. But when it comes to 25, 35 and 45, the point on the green always falls below the orange. Okay, so in these higher marks, 25 or 35 or 45, you always have the orange class, that is the section A, outperforming the green class, which is section B. So from this frequency polygons, we can conclude that students from section A have performed better than students of section B.
We have thoroughly studied, digested, thought about and simplified the concepts for you. So please like, share and subscribe.